So now what we'll have to understood is balancing a beam. So our next topic is balancing a beam. So how we will balance a beam about a pivot. Okay, like the ruler in figure. So you can see here a figure of 10.2. The weight must be moved so that the clockwise turning effect equals to the anti-clockwise turning effect, and the net moment on the beam becomes 0. So let me elaborate this with the help of an example. So here we have a basic simulation here. So what will happen, I have two bricks already here. Okay, so I have already have two bricks like this and this. So if these bricks are already placed, so that's how the moment of force, if we calculate the moment of force here, let me calculate the moment of force here. So the mass of the object is 5 into the, you can see that if we multiply it by g, you know that the force is applying here is weight of the object. The force applying here is the weight of the object, so that is w1 and that is w2. So the weight, the formula for finding the weight of an object is mass into gravitational acceleration, that is small g. Very small g, the value of small g is 9.8 meter per second square. Okay, so now if we calculate the moment of force here, so how we can calculate the moment of force here? We can simply calculate the moment of force by using the force here. So force is weight here. Okay, as I already told you that force is weight here. So weight 1 into the distance between the hinge point and the point of application of force, that is 2, equals to the W2, that is the weight of the second object, into the distance between the hinge point and the point of application of force. So this 2 and this 2 gets cancel out. So the case is here is W1 is equals to W2, which is we can see here that the weight of these two objects is same. Okay, so now what will happen if I change the weights here? So let me change the weight here. Now what will happen if I remove this 5 kg? Now it is applying the turning effect in the, let me take the 5 kg back. Now it is applying the turning effect in the anti-clockwise direction. Now what will happen if I take this 5 kg object and place it at the end point? Now it is applying the same force at the clockwise direction. To balance it, we need to apply the moment of force of both direction to be 0. Okay, so here it is written here that the weight must be moved so that the clockwise turning effect equals to the anti-clockwise turning effect, and the net moment on the beam becomes 0. So how we can do that? So there are two ways to do this. The distance of the turning effect should be equal. Now let me show you how you can do this. For example, if I place the 10 kg object here, now the turning effect is not equal because if we calculate the turning effect here, so the force is here is 10 into g, that is gravitational acceleration, into the distance is 2, and if we calculate the left part of the moment of force here, so that is 5g into the distance is 2 here. So if you calculate this, that is 10g and that is 20g. So now here it is not equal. 20g is not equals to 10g. You already know that. So that's why this object is applying more turning effect than this object. So how can we balance it? To balance it, we have to change the distance. Like for example, if I change the distance here, now at this point the moment of force of 5 kg object is greater. 5 kg object is greater, the moment of force of 5 kg object is greater than the 10 kg object. Now if I will place this 10 kg object at the point where it will get balance, like if I place it at the one point, now if you will calculate the moment of force of the left point, if you calculate the moment of force of the left point, it will be equal to the moment of force of the right point, irrespective of their masses to be equal. So this is the basic understanding. You will just have to play with this simulation. I will give you the link in the description so you can play this simulation.